Hi everyone, welcome back. Some more examples of the chain rule. Let's see how simple they can become. I'll let the inside equal u. So I can differentiate that as du dx, differentiating the expression called u using the letter x. So that's just a normal everyday 6x, and what happens to the 1? It disappears and it becomes nothing. So now I have a new expression called y equals u cubed. I've replaced the inside by u. I can get dy du as 3u squared. Now in comes the chain rule. I didn't want du dx, I didn't want dy du, I wanted dy dx. There's how I write the dy dx, and I can put whatever letter I want here, as long as I put it on the top and on the bottom. So dy du, get the right one in the right place, is 3u squared. And du dx is 6x. Now we're going back to substitute. U equals 3x squared plus 1. Back to where we started from up here. We've got 3 bracket, don't forget the brackets, I say it every time, with a squared times by 6x. And of course you can simplify that and do all sorts of things with it. The most obvious one is to go 6 3s or 18x outside of 3x squared plus 1 all squared. So that's with the chain rule. Now this is still the chain rule, but it's just an observation of the chain rule. So if I start with the same question, every time you get something more complicated to a power, the same rules apply. The derivative is the 3 is multiplied by the front, which is 1, 3 1s are 3. And what do you do with the powers? We're doing the DDs. So when you're differentiating, the powers decrease. Too many people make silly mistakes and write 4 instead of 2. So I go down by a power of 1. And then it's more complicated. It's more complicated than, for example, if we just have y equals x cubed, dy dx would be 3x squared. So we've just done exactly like you did with an x cubed. But it's more complicated. How much more complicated is it? This inside, actually it's the whole of the inside, I multiply by the derivative of the inside. So the derivative of the inside, the derivative of 3x squared is just 6x. If you have a look over here with the chain rule, we've just done the chain rule without writing down what u is and differentiating and put the parts together with the chain rule. So the question will always work the same, always works well, and it becomes very quick. So then I could tidy that up the same as the other one. Then I've got the 18x outside of 3x squared plus 1 all squared. And that's our derivative, which is an expression of the gradient. Just going to go to a couple more examples which students tend to make mistakes on assessments. Now here's 2 further examples where it gets a little bit more complicated. So first of all, always talking about we have to rearrange first. We haven't learnt how to differentiate with a square root. So if I wrote that as 2x minus 10 to the power of a half, because remember the square root means to a power of a half, now it's written in a form that I can straightforward differentiate. Yes, I could now go let u equal 2x minus 10 and I could use the chain rule. So instead of doing all that, I can just go y dash is, of course you're going to multiply the power by the front, so a half times 1 is a half. And what do you do with the power? Decrease the power by 1. Now the interesting part is I always talk about the insides stay the same. So this concept all the time that the insides stay the same. So you're going to have it over and over again. The insides controlled by that square root or that bracket there or that bracket there, they stay the same. Now the big thing is, what does everyone forget? I talk about one that people forget. That's the derivative of the inside. So what do we multiply by? The derivative of 2x take 10 is just 2. So now the rest is just algebra and simplifying. So let's have a look at what we did. You have to rearrange first, do your normal differentiation, don't forget to decrease the power by 1. And the big part is, don't forget to multiply by the derivative of the inside. I have seen, I could say thousands, at least hundreds of questions when I mark assessments from my students I teach, and I nag about it, talk about it, remind them about it, and they come into the assessment and they forget to write times by 2. Some of you watching will do it. Hopefully you'll make a decision not to be. So we've actually just got a half times 2, which is 1, so I don't have to write that. So I could if I wanted to. There's my 1. If it's a numerator, of course, I have to write the 1. Why did I write it as a 1 up here? Because this is just a normal everyday 1. Minus means we're going to go to the denominator with a square root. So minus is a, move to the denominator, or if it was on the denominator, move to the numerator, put a square root of what we started with, 2x take 10. There's a question done. So here's a twist to it. It isn't a square root, but there it is on the denominator. Now I don't know how to differentiate an expression where we've got x on the denominator. So we need another method. So here's the method we're going to approach it with. So first I'm going to talk about we have to rearrange. Cannot differentiate it in that method. So remember that a fraction bar means that there's a bracket around all of that. It's actually a bracket with a power of 1. How do I move from a denominator back to a numerator? Sorry, I laugh because I'm saying the same things over and over again. Part of my life as a teacher, so if I'm not differentiating yet, I went to say it, differentiate. I can write this 3x squared plus 4, instead of being on the denominator, now it's on the numerator. This was a power of plus 1, now it's a power of minus 1. Now it's in a form that I know how to differentiate by the only rule. Not proving this by first principles. Yes, I could prove that by first principles. Yes, I could prove that by first principles. But at this stage, we're just going to go through the actual operation. No one's going to ask you in Australia to do that by first principles and a year 12 assessment. Oh, I suppose some teachers could think of it, but no, I can't see it happening. So the derivative is, you multiply the power by the front, minus 1 by 1 is minus 1. And then you go, the inside stay the same. The minus 1 becomes a minus 2. So what are you doing with the power? We're doing the DDs. Decrease the power by 1. So if you decrease minus 1 by 1, you're at minus 2. And the big thing that everyone forgets, multiplied by the derivative of the inside. So the derivative of 3x squared is 6x. So let's have a tidy up. And what are we left with? Minus 1 by 6 is minus 6, and that's a numerator. It's not a denominator. There's the x, it's also a numerator. And what do I do with a minus power? I move it from, here it is as a numerator, I move it to the denominator. 3x squared plus 4, brackets around it, all to the power of 2. And there's a couple of cases of doing the chain rule without writing the chain rule down. This will go to the highest level, and you can simplify the most complicated questions in spec by just what I would call observation, or writing down the obvious patterns of what you do with that. If you're enjoying it, please just let your friends know.